Hi guys, welcome to Code Decode. So today we are going to cover the advanced Java interview questions topic, which is Hibernate. So let's get started for that. The very first question which may arise to you in an interview is what is Hibernate and why to use it? So the Hibernate is nothing but an object relational mapping tool. So this is ORM tool, object relational mapping tool, used to map Java objects, which are the objects, and relational means database tables. So if you have a Java object and you have a database table, how do you communicate with the object oriented thing with the database thing? That is how you do with ORM. So Hibernate is nothing but an ORM tool. Now the next question arises is how does this mapping is done between the object and database tables? So basically Hibernate provides you two methods so that you can connect with your database tables. The first is the annotations, which is the JPA basically annotations, and the second is XML configurations. So XML configuration, I understand that this is something related to Hibernate like .xml files and all. But how come Hibernate uses JPA annotations? The interviewer may ask how can in Hibernate you can use JPA annotations. So the answer to this question will be that Hibernate is nothing but an implementation of JPA. JPA is just like an interface and Hibernate is just like a class. So JPA provides you some interfaces and how to do it, but what to do, but how to do is actually defined by Hibernate. So this is nothing but an implementation of JPA. Hence you are able to use the JPA annotations while connecting to your objects to your database tables. Now a very important question which arises in many of the interviewers is that why Hibernate? Why not JDBC? As in, why do you actually need to move to Hibernate if you already have JDBC in place? So if you like give an answers in such a way that yes, my project uses Hibernate, they will really ask you why Hibernate? Why not use the simple JDBC? So the answer you will be giving to that particular thing is that Hibernate eliminates the boilerplate code. Now the next question arises, what is the boilerplate code? So boilerplate code is nothing but the extensive coding which is required for making the JDBC connection to the databases. So many times you have to write the same type of code again and again to do one particular kind of transaction or something. So it eliminates the Hibernate, it does it all for you, and you just have to focus on your logics. You don't have to need to think about those boilerplates or boilercode plates or the repetitive code that you have to write with JDBC. It is actually done under the hood. The second important reason why we use Hibernate is because of Hibernate query language, and being an object-oriented developer, I always prefer moving towards the object-oriented technologies rather than using the JDBC or the legacy ones. The third important thing is that it provides transaction management implicitly. So in JDBC, you have to manage the transactions by yourself manually, but in here, transaction management is actually done for you by Hibernate itself. So you don't have to worry about it. The fourth important reason why I use Hibernate is because it shows JDBC exception or Hibernate exception, which are unchecked exceptions. So I don't have to use try and catch manually. If you write JDBC, then you always remember that you have to use try and catch, and then you have to handle your exceptions there. But Hibernate actually converts all your checked exceptions into unchecked exceptions. And since they are unchecked exceptions, you don't have to worry about handling it. If some error comes, it will automatically let you know. The last important reason why I use Hibernate in my project and not JDBC is that Hibernate supports caching for the better performance. I'll be covering this in the later topics. The second important question which will arise for sure is what are the interfaces that you use in Hibernate. So there are basically three important interfaces which you use in Hibernate. The first is Session Factory. So why do you use this particular interface? Because the instance of Session Factory is used to retrieve the session object. And we need to initialize this once, and we can always cache it and reuse it again and again. But you have to remember one thing very, very importantly, that the Session Factory object is per database connection. So if you have one for Oracle, then you have to create another Session Factory for connecting to MySQL or another type of databases. So remember Session Factory, with Session Factory you can get the session object. Now what is session? Session is nothing but an interface, important interface used in Hibernate, and it is again a factory to transaction. So from session factory you get session object, from session you get transaction object. And why do you need session object? Session object is used for connecting your application or the object with the persistent store like Hibernate framework or databases. So basically it is used to get physical connection with the databases. So it's very important thing. If you don't have session, you will not be able to make the connection to databases. And basically it provides the CRUD operations like create, update, delete, or something for the session part. So this is how you make all your operations done on your databases. Transaction. What is transaction? A transaction is nothing in an interface which is used to specify a single atomic unit of work. So you know what transaction is, right? I can start a transaction. I do some particular operation like CRUD operation. I create something. I read something from database. I update something in database. I delete something in database. What will happen? All these CRUD operations may be part of one transaction, and once it is done, I can commit it. If it is failing, then I can roll back that particular thing. So these are the three important interfaces. I'll show you in a diagrammatical way that a session factory is the parent of all. With the session factory, you can always get the session object. And once you get the session object, you can get the transaction object. So how do you do that? Now this was the logical implementation. But how do you do it in programmatical way? The interview may ask you that. So this is the code I have given to you. The metadata with the get session factory builder, you can get the session factory object. So once you have a factory object, you can do factory.openSession. Once you open your session, now you can create a physical connection with the databases. So with this session, you begin your transaction, and as soon as your transaction begin, you can, in the session object, you can save something, you can get something, you can update something, you can delete something in databases. And once everything is done, you can commit your transaction. So once you have the transaction available with you, with the begin transaction from the session object, you can commit it. Once your with this commit, your transaction is completed. So now you don't need your session because your transaction is completed. So you need to first close your session, and then you have to close your factory also. So remember, if you open a new session, always close it. This is how it is done. The third important question which arises, what are the annotations used in the Hibernate? So these are some annotations used. The entity, why is it @entity used? @entity is used to specify that these are entity beans. Means they are going to be stored in the tables. What is this @table used for? It is used to define the corresponding table name. So if on a Pojo class you have written @entity, but it should be mapped to some table. So how do you say that this particular entity is mapped to this particular table? So this particular annotation @table is used. Then what is access annotation? It is used to define the access type. So it can be either field or property. The default is field, but if you want to use the getters and setters method that you need to set the property, then you have to always use access type.property and use this particular thing only if you are very sure that you're going to use the getters and setters and not the property or the field itself for getting and setting the values in the Hibernate from the table or into the table. The fourth important is @ID. It is used to define the primary key in the entity bean. So @entity is the class level, @table is class level, but @ID is the field level annotation. What is @embedded ID? Embedded ID is used to define a composite primary key, because every time you are not going to have a single primary key in your table. If you have two or three columns making together as a primary key, then you have to use @embedded ID. Then what is @column? It is used to define the column name. This is similar to @table. So @table is class level thing. It used to define the table name. @column is a field level thing. It is used to define a column name. Then generated value. Basically, this is used for generation of the primary keys. I always prefer the identity one. So I have given an example of this, the generation type.identity. So this is always used with the conjunction with the generator type, because this is an enum. And it is used to define the strategy with which you are going to generate your primary key values. The another one is one-to-one. This is used for one-to-one mapping between the beans, and similar to this we have one-to-many, many-to-one, or many-to-many. I'm going to cover this in the next few seconds. The next is @cascade. Cascade is used for the basically cascading between two entity beans used with the mappings. It works in conjunction with the cascade type. Similarly, the last and the very important one is primary key join column. I'm going to show this in the next few seconds, but understand that it is used to define the property for the foreign key. So if I have a table employee, I have a table address. So if address is in case it is a foreign key, then you have to use primary key join column on the address, so that you don't actually end up in adding some of those addresses which are not already in the address table. So this is how you use this particular annotations, and that was all about these annotations. Next question that may arise is, what are the type of mappings in Hibernate? So something we have done like 2 seconds back, I have told you we have annotations. So basically we have 3 type of annotations and 3 types of mappings, association mappings in Hibernate. That is one-to-one mapping, many-to-one mapping, and many-to-many mapping. So what this one-to-one mapping says, I'll give you an example. If I have say employee and say I have a phone number. So employee has one phone number, and similarly this phone number will always be mobile number will always be associated to one employee. So this is one-to-one mapping. Only one particular instance is applicable to one particular instance of the another object. So one mobile number is associated only with one employee, and one employee is associated with only one mobile numbers. Maybe there can be chances, but I'm taking that particular case that it is always one-to-one mapping. Now many-to-one mapping, you can always say that many employees can stay at one particular address, but one address belonging to many employees. So that is how many to one works. And many to many, I'll give you one example here. So like, what about the code part? So that was the logical one, that it has mapping of one to one, many to one, many to many. So but how do you explain that to an interviewer in the coding format? So this is how you do in a coding format. If you have a class employee and I have a private code decode variable, and it has one-to-one mapping, so it has one-to-one with a target entity is code decode.class in the employee class. So this is how you make a one-to-one mapping. Now what about many-to-one mapping? So I have a student, I have an address. So the example I've just told you, that I have many students staying at one address, maybe a hostel type of thing, right? So that can be a situation where you can denote it with the programmatical way with @many-to-one and cascade type all annotation. Now many-to-many example. Now suppose I have a student class and I have a degree class. So I have one student can have many degrees, like I can have BSc, MSc, BE, BTech, anything. So one student can have multiple degrees. Similarly, one degree is not allotted to just one student. So BE might be a degree done for multiple students. So for one particular degree, there can be multiple students enrolled into it. So this is how you do the many-to-many mapping. But see, one-to-one and many-to-one on one-to-many is like less complicated, because it has only 2 tables and this is how you map. But in many-to-many, there is a third table created automatically into the database. So even if you see only 2 classes, a student class and a degree class, but still there will be third table created apart from student and degree, which will be named as degree student third table, which I have given here as of now. Why I have given that particular thing? Because I have many-to-many relationship between student and degree, that is student class and degree.class. But how do you actually map these into the databases? So there will be third table created named as whatever name you give XYZ here, and then there are 2 properties, join column and inverse join column. So suppose I have student ID 1 which is degree 1 and 2. I have student 2 which is also degree 2 and 3. So there will be third table created where it will be 1, 2 and 1, 2, 3. So these type of mapping will be done in the third table, where the join column will be the primary key of the class in which we are creating. So the student's primary key will be join column, and to which you are connecting to with a many-to-many relationship, that is degrees primary key will be inverse join column. So remember, these 2 are the very important things, and this is always asked when you appear for the Hibernate interview, that in many-to-many the third particular table is created, and basically two extra fields are added, that is join column and inverse join column. Join column will be the primary key of the current class, and inverse join column will be on which you are using @many-to-many relationship, that is degree.class. So that will be inverse join column. So I hope this much is clear. Let's move on to the next question. The 4th question is, this is very important question, what are Hibernate configuration file? So Hibernate configuration file is something which looks like this. So why do you need Hibernate configuration file? Because somewhere you have to put your database properties, like what is the database and what is the driver. So I'm using the Oracle driver here. What is the username? Code decode. What is the password? Code decode. What is the URL to connect? What is the dialect? How do you want to make this auto, or you want to make it non-updatable? How do you want your mapping resource to be in the XML, hbm.xml? So all these database related initializations are actually done here. Once you have all the properties here, these properties are used to initialize your session factory. Remember, I've told you session factory a second below, that it is used to get the session object with which you can create a database physical connection. So with this particular database connections available to you, you will be able to create your session object. Conventionally, this is named as hibernate.cfg.xml. Very important question which is asked in this particular file is, fine, you have given Oracle driver here. Now I want to connect to the SQL database. This is a different database. Then what will happen? Will this session factory work? So the answer to this question will be no. You need to create another session factory with the different properties, because all the properties will be different when it comes to the different databases. So if you have n number of database connections you have to create n number of session factories. So this is how you create n number of session factories in your Hibernate configuration file. The parent is Hibernate configuration. So I hope I'm clear with the Hibernate configuration file. Let's secondly go quickly to the Hibernate mapping file. This is another second important file you have in your Hibernate. So first, what you have done, you have actually created your this particular thing, Hibernate configuration file. But now what will happen if you have all your database connections already in place, but now you have to map your tables to your objects? Then how will you map your object with your table? So this is Hibernate mapping file. Conventionally it is always named as whatever your class name .hbm.xml. So suppose I want this mapping file for my employee class. So this will be employee.hbm.xml, similar to something I've shown you here, right? Employee.hbm.xml. So this is your mapping file. So employee, this is my class name. So let's start it from the first part. The root element is Hibernate mapping. Then the interviewer may ask to explain all these properties. So what you will say, the Hibernate mapping is the root element. The child or the subchild of this Hibernate mapping is the class. Class actually defines the persistence class. So employee is my class which I want to persist, but in what particular table you want to persist? So it will be EMP table. Now if you have your class in place, the subchild of class will be ID, because I agree that the table must have some primary key, and even this should have some primary key. So how will you define the primary key? With the ID, the name as ID. But fine, okay, that is also fine. But how you want your tables to generate this particular ID, say employee ID 1, 2, 3, 4. I want it to be either assigned or something auto generated. So that generator class will be defined here. So Hibernate mapping has a child which is class, then it has a child which is ID, which has a subchild that is generator class. Now parallel to ID you have property child. This property child is nothing but used to specify the property names of the persistent class. Say for example, first name should be persistent, last name should be persistent. So that was all the childs of class tag. Now this is how you add your root element Hibernate.mapping. So that was all about the Hibernate mapping file you have for any of the class you have for the persistence purpose. Now the sixth important question which may arise after this is that now if you know about the mapping files, if you know about the Hibernate configuration files, now can you can you give me some simple steps how you actually end-to-end create a Hibernate application? So this is very important thing. You should be thorough with your logics, that first you have to create a POJO which is nothing but a persistence unit for you. Say for example, I want to persist my employee object into employee table. So first you have to create a Java object for that. Once you have created the Java object, you have to create a mapping file. Once you have created the mapping file, the one I've shown you just 2 seconds back, where we have employee, we have class, we have generated IDs, we have properties, the one I've told you with the subclassing thing. Once you are sure that your particular object is having perfect mapping with the table, now you have to create a configuration file. So this is the place where you start creating your database connection. So this was Java. This was all Java, and from here you will start connecting to databases. So for creating to database, you have to create a configuration file where you will give you the driver name, the dialect name, and all the session factories that you need for creating the connection to the databases. Once you have created your database connection, the last thing you have to do is to write a class, which is an implementing class, which is used for storing or getting the data for, using the POJOs from the table. Like using POJO, you can put some data into table, or you can fetch some data into your POJO into your Java application. So you need some utility class for that. This is also Java part. Once you have get this, you can run your application and you can check your results. So these are simple 5 steps you need for sure to implement your Hibernate application. The 7th important question which arises, what is the difference between openSession and getCurrentSession? So this is a very common question which is asked, but you need to get into the concepts of it. getCurrentSession actually returns the current context session. That is the current session which is going on. So this session object actually belongs to the context of the Hibernate. So it is okay if you don't close it. Once the session factory is closed, this current section will automatically get closed. So you don't have to explicitly write a code to close it. But while you use openSession, remember, while this particular method is used, you always create a new session and you don't use the session which is already in the context of Hibernate. So once you create a new session, you have to make sure that you also close it once you are done with all your operations. So closing this particular session is very important. And also you should open every new session if you are using a multi-threaded environment. So every time you get a request, you have to open a new session for it in a multi-threaded environment. The 8th most important question which arises, what is the difference between get and load methods? So both the methods are nothing but actually used for getting some data. But get loads the data as soon as it is called, but load actually returns a proxy object and loads data only when it is actually required. So very first important difference between both of them is the load actually supports lazy loading, and hence the performance of load is far more better than get. But if this is so good, why not I should use load only? Why do you need a get? Because load throws an exception whenever you don't get a data in the database. So if you're very sure that you are going to get the data, then only use load. Otherwise it will give you an exception and your code will block then and there. So that is why you can use get, because when you want to make sure that yes, data is there. If you're not sure that okay, data may be there, may not be there, but I just want to know whether it is there or not, you can use the get method. So if you're very sure that you know the data is there in the database, you can use load because it is very good in the performance wise because it is lazily loaded. But if you're not sure the data will be there in the database or not, and you don't want your application to abruptly stop then and there, use the get method. Okay, now the last thing, which is very important part of the whole Hibernate thing, is the caching part. So the interviewer will for sure ask you, like this is like 100% surety, that if you are giving an interview for Hibernate, they will for sure ask you about caching part, because this is the very important property of Hibernate. So the first, what are the types of Hibernate caching you have? So there is a first level cache, second level cache, and query level cache. So now the questions won't ask here, won't stop here. The questions will move ahead and they will ask you what is first level cache, what is second level cache, and query level cache. So let's get started for the one by one questions for each. And the first level cache is nothing but it actually is, firstly, it will ask you why caching, why not JDBC or simple no caching technique. So caching is nothing but it used to make our application faster and improves the performance, because if you have some data into your cache, you don't have to go hit the database again. So the basic idea behind caching is to reduce the number of database queries. If you have less number of database queries, you have lesser number of hits to the databases, and hence your performance will automatically increase because time will automatically get reduced. So the Hibernate has the first level cache which is associated with the session object. So remember, the session factory gives you the session object. That session object automatically has the first level cache associated with it, and it is by default enabled, and there is no way you can disable the first level cache. Hence, Hibernate actually gives you some performance by itself by giving you the first level cache automatically enabled into the session object. But do you think there is any way through which you can delete the session object, or a way where you can clear the cache completely? Yes. Hibernate is not that inflexible for you. It actually, Hibernate provides you some methods which with you can actually clear your cache completely, and then you can start over all again. So any object cached in a session will not be visible to other session. Why? So this is a very important interview question. So an interview may confuse you or trick you with asking that if the first level cache is associated with a particular session object, will that particular object which is being cached will be visible to another session, or what will happen when the session is closed? So the answer to this will be that if you have something enabled in your first level cache, an object is in your first level cache, then that won't be visible to another session. Simultaneously, if in case your session is closed, all the cached object in the first level cache will be lost. So this is very important thing to understand about first level cache. So you understand that as soon as your session is closed, everything is gone. That is why there is a concept called as second level cache. Now second level cache is basically by default disabled, but we can enable it through configuration. I'll tell you how. And there are basically few implementations for enabling the second level cache. The two important such level caches, EHCache and InfSpan, provides the implementation for the second level cache, and we can use them. But I always prefer EHCache over everything because the performance is far more better. So even if you say that yes, you prefer EHCache, he will for sure ask you how, if you have used EHCache in your project, how did you use it? So the answer to this question is very straightforward. There is only 4 steps required. The very first step is that you need to first enable EHCache by using the dependency in your Maven project, or if not, then you have to implement it using the jars and add it to your build path. So Hibernate EHCache of org.hibernate is the way how you can implement your EHCache in your project in the Mavenized project. If not, then a jar of it. This was first step, implement EHCache jar. The second step for the same is to add the below property in Hibernate configuration file. I have already shown you configuration file. Now in there only you have to write these particular line of codes, that is your region factory. So this particular is nothing but your EH factory. What do you do with the factory class? You actually get your object of EHCache. Simple as that. Now the second level cache, yes, I want to make it true. If you make it false, your second level cache will not be enabled. Your query level cache, you should always use, remember this is a very important interview question, query level cache should always be used in conjunction with second level cache only. Query level cache will never work with first level cache. So for making a query level cache true, first make the second level cache true. Now what is the XML file where all your EHCaches configurations will be done? So that for me it is code decode EHCache.xml file. So you have to give your XML file name here in your Hibernate configuration file, where you have one object created for the factory where you will get the EHCache object. Then you have your first level, second level cache enabled, your query level cache enabled, and your file name where you have EHCache enabling properties available. So the third important thing which is very obvious from here is you need to create your code decode XML. So before creating this EH configuration file, I have given you a sample of it, but first understand, because if the particular interviewer may ask you to explain whole EHCache configuration file. For that you need to understand that the very important thing is disk store. So what will happen if my cache overflows? Say I have 10 objects capacity on my cache, but I have to cache 11th object also. So this is the path where my overflown cache data will be stored. Okay, then the second important thing is the default cache. So this is actually the place where all your regions will be decided, or if there's something called as default caching place. So the total time and IDs, time to live, these are the default, and this is the very important configuration. This is compulsory configuration you have to give. So this is the default cache regions properties that you define here. Now cache name equals to employee. So this is nothing but cache's region. So there is some region in cache, right? So in that region, I am defining that maximum entries are 1000, the time to live is 10, and the strategy will be local time swap. But it will be very easy if I name this particular cache region. So I've given it a name as employee. So this is how in the configuration file you define different regions in your whole cache. This is how you define how my cache will look and what will be the regions. So there is basically two more regions: standard query cache region. All my queries will be actually like if this is a standard query region, then all my queries will be cached here. There is update timestamp cache. This is another region where you will have your update timestamp cache with all these common persistent strategies. So we have seen 3 steps there. The first one was to get your dependency. The second one was to create the configuration file where you define where my EHCaches or XML configurations will be there. Then you have to define that particular XML file. And the last or the fourth step is now use your caching technique. So how do you actually use your caching? So I have my entity, @entity. I've already shown you this. Like we have some classes, the Pojo, which is to be persistable. With @entity, you have a table. And then this is a very important thing where you use your caching part. @cache usage is this particular strategy which defines how your strategy for caching will be and the region name. So in the previous slide, I've shown you that in a whole cache part, you have different regions and you have named that region with name equals to employee. I've shown you, right? So I have cache name equals to employee. You remember this name, employee? This particular name is actually used here, and whatever data is required to be cached, this particular name of region will be found in that particular cache location, and all your data from this particular cache will be cached or stored into that particular region only. So this was all about how you enable EHCache in your application. If you want me to give you a live demo on this, please let me know in the comment section. This was all about I have for this particular Hibernate questions because the time is running out. If you need more of such questions, please let me know in the comment section. Then only I will create a second session which will have the high level interview questions for the Hibernate. Only if you allow me in the comment section, then only I will create the second part with the high level Hibernate configuration questions for you. That's all. Thank you. We'll meet in the next session. Thank you.